Q6608-3. The purpose of a horizontal stabilizer on a helicopter is to provide a fixed surface to improve speed in flight. B. Sufficient controllability of the aerodynamic pitching moment of the fuselage. C. Adequate cyclic control travel when operating at or near CG limits. The correct answer is B. The purpose of a horizontal stabilizer on a helicopter is to provide sufficient controllability of the aerodynamic pitching moment of the fuselage. In a helicopter, the horizontal stabilizer is a fixed or adjustable surface located on the tail section of the aircraft. Its primary function is to assist in controlling the aerodynamic pitching moment of the fuselage. The pitching moment refers to the tendency of the helicopter to pitch nose up or nose down about its lateral axis. By adjusting the angle of the horizontal stabilizer, the pilot can influence the aerodynamic forces acting on the tail of the helicopter, thereby controlling the pitching moment. This allows for better stability and control during different flight conditions, such as forward flight, hover, or maneuvers. The purpose of the horizontal stabilizer is to provide sufficient controllability of the aerodynamic pitching moment of the fuselage. It helps the pilot maintain control over the helicopter's attitude and stability during flight. 6610-1. As each blade flaps up and down, it produces a shift of the center of its mass. When the blade flaps up, the CG moves closer to its axis of rotation, giving that blade a tendency to a. Accelerate its rotational velocity. This tendency is known as Coriolis effect. B. Stabilize its rotational velocity, thus compensating for dissymmetry of lift. C. Decelerate its rotational velocity. This tendency is known as translating tendency. The correct answer is A. When a helicopter's blade flaps up, the center of gravity, CG, of the blade shifts closer to its axis of rotation. This shift in CG creates a tendency for the blade to accelerate its rotational velocity, and this phenomenon is known as the Coriolis effect. As the blade flaps up, the shifting CG changes the distribution of mass in the rotor system. This creates an imbalance in the forces acting on the blade. According to the principles of conservation of angular momentum, the blade will try to maintain its rotational momentum. However, due to the shift in CG, the blade experiences a change in its moment of inertia, resulting in an acceleration of its rotational velocity. The Coriolis effect is a result of the conservation of angular momentum and is characterized by the acceleration of the blade's rotational velocity when it flaps up. This effect helps to maintain the overall balance and stability of the rotor system. It tends to accelerate its rotational velocity, and this tendency is known as the Coriolis effect. This effect plays a role in the dynamics of the rotor system and is an important consideration in helicopter aerodynamics. 6503. Rotor blade rotation during powered flight in a gyroplane is produced by the A. Horizontal component of rotor lift. B. Interaction between engine propeller thrust and rotor blade drag. C. Transfer of engine power through the clutch to the rotor shaft. The correct answer is A. During powered flight in a gyroplane, the rotation of the rotor blades is primarily produced by the horizontal component of rotor lift. As the gyroplane moves forward, the relative wind creates an angle of attack on the rotor blades. This angle of attack generates lift, which can be divided into vertical and horizontal components. The vertical component of lift supports the weight of the gyroplane and counteracts the force of gravity. The horizontal component of lift acts in the direction of flight and contributes to the rotation of the rotor blades. This horizontal component creates a torque that causes the rotor blades to rotate around the rotor mast. The rotation of the rotor blades is a result of the gyroscopic effect. The rotor blades are attached to the rotor hub, which is connected to the mast. As the horizontal component of lift is generated, it exerts a force on the rotor blades that causes them to move in a circular path around the mast. This rotation is what provides the gyroplane with its lift and stability during powered flight. Therefore, the The correct answer is that the rotation of the rotor blades during powered flight in a gyroplane is produced by the horizontal component of rotor lift. This component acts in the direction of flight and creates a torque that causes the rotor blades to rotate. 6614. In preparing to take off in a gyroplane, your student engages the clutch and pre-rotates the rotor to take off RPM. If brakes are released prior to disengaging the clutch, the gyroplane will turn A. Left because of rotor torque. B. Right because of rotor torque. C. Right because of engine propeller torque. The correct answer is B. When preparing to take off in a gyroplane, the rotor is pre-rotated to the takeoff RPM using the clutch. Once the rotor reaches the desired RPM, the brakes are released to allow the gyroplane to start moving forward. At this point, the gyroplane is still on the ground and the rotor is producing lift. The rotor of a gyroplane experiences torque reaction similar to a helicopter. As the rotor spins in one direction, an equal and opposite torque is applied to the airframe in the opposite direction. This torque reaction tends to rotate the gyroplane in the opposite direction of the rotor rotation. In this scenario, when the brakes are released and the rotor is engaged, the rotor torque will cause the gyroplane to turn. Since the rotor is rotating in one direction, the gyroplane will tend to rotate in the opposite direction. Therefore, if the rotor is rotating clockwise, when viewed from above, the gyroplane will tend to turn to the right. It's important to note that this turning tendency is a result of rotor torque, not engine propeller torque. The engine propeller torque refers to the rotation of the gyroplane caused by the engine's propeller. However, in this specific scenario, the engine propeller torque does not come into play because the gyroplane is still on the ground and the engine propeller is not providing thrust. Therefore, the correct answer is that if the brakes are released prior to disengaging the clutch, the gyroplane will turn to the right because of rotor torque. 6615-1. What changes take place regarding lifting force and load factor produced by the rotor system when a gyroplane goes from straight and level flight into a 45 degrees bank turn while maintaining constant altitude? A. Total lift must increase. Load factor will increase. B. Total lift must increase. Load factor will remain constant. C. Total lift will remain constant. Load factor will increase. The correct answer is A. When a gyroplane transitions from straight and level flight into a 45 degrees bank turn while maintaining constant altitude, several changes occur in the lifting force and load factor produced by the rotor system. First, let's understand the concept of load factor. Load factor is the ratio of the lift force acting on the gyroplane to its weight. In straight and level flight, the load factor is 1, meaning the lift force is equal to the weight of the gyroplane. In a bank turn, the load factor increases because the gyroplane is now experiencing a horizontal component of lift in addition to the vertical lift required to counteract gravity. As the bank angle increases, more of the lift force is directed horizontally to support the centripetal force needed to maintain the curved flight path. Now, in a gyroplane, the rotor system produces the lifting force. In a 45 degrees bank turn, the total lift must increase to provide both the vertical lift to counteract gravity and the additional horizontal lift for the centripetal force. Therefore, the first part of the correct answer, total lift must increase, is justified. Furthermore, since the load factor is the ratio of lift to weight, and the total lift increases while the weight remains constant, the load factor will also increase. The increased load factor indicates that the gyroplane is experiencing increased forces and stresses during the turn. To summarize, when a gyroplane goes from straight and level flight into a 45 degrees bank turn while maintaining constant altitude, the total lift must increase to provide both vertical and horizontal lift, and the load factor will increase due to the increased lift.